you're there, I'm just setting up. There in 2 seconds. Right. Well, I'm just setting up. I'm just going to send this to Gav here. Have a wee chat. Hang on. How we doing, people? One Man, Wheeler Antiquity, Eyes Wide Shut, Boris Chops, Rambo, Old Dude Mark, Tony Dixon, Lee Redpath, Stuart Lundy, Scotty Boy, Latimer Allman, from Newcastle, hello, Ronnie Martin, how we all doing? I'm just waiting Gav arriving here. What's the topic tonight, Del? Says it in the title. We're going to have a wee chat about geometry in regards to optics. I think Gav's going to present some stuff and have a wee chat. Have a real He's there. Alright, my man?
Hey, Dale.
Alrighty.
Yeah, alright. Can you hear me okay?
Hi, fine, mate. Sounds good.
Are you live already? Or?
Aye, that's us. We're on, mate. We're on.
Alright. Good to have a wee chat again.
Yes.
I've been away for a while, but it's not as if I haven't been thinking about it every day. But,
Yeah.
you know, lived life and all that.
Yeah.
Stuff to do. So, but now that the weather's drawing in and it's getting darker, there's plenty of time in the evenings now to contemplate.
That's
so.
it. It means what you mean as you've got fuck all else to do.
Aye, exactly. The nights are fair drawing in, so hopefully it'll not be the last chat we have.
Yeah. I'm going to share the screen that's Gav so that it's showing you the now, right?
Aye, no bother, right. Makes a change from your ugly mug.
Exactly. A different picture. So, I'll let you do the introductions this evening then. Away you go.
Away I go. You take the night off, are you?
Right.
Well, what I thought we could talk about, Dale, is obviously the whole topic around vision, right? Visual perception, visible geometry, and it's part of basically, how should I say, still an inquiry to find out how they did it, how they did the globe switch, right? Mm-hmm. To make us all believe we're living on a ball, and everything they tell us, every proof they bring us, every example, or where they try to bring their arguments, they always leave out the geometry of vision and how we perceive the world. And any real true inquiry can't be done without that, Dale, right? No. So I think we've said this many a time in the platform, right?
Just to reiterate it, every single aspect of the globe that comes with its evidence or its proofs or whatever they want to call it, it's all visible phenomena.
Right.
There isn't anything else. They don't have any direct measure or practicality. It's just all, based on language.
Absolutely. It's all, playing with mathematical definitions, or playing, on what vision does, right? As you correctly say,
Yeah.
What are proofs, they're wrong anyway.
Yeah.
And so we don't really need to, this exercise at looking at how vision works is just, general natural philosophy, right? Trying to understand how perception and visual perception and knowing your own mind and knowing your own body, how it all works, right?
Yeah.
So we don't need it to know they're wrong,
yeah. But it's also good in educational purposes. Sorry for cutting in, Gav. That
No.
that we try and establish, a reverse engineering of how they established the globe model in the first place.
Exactly. Right.
So I think
And
that's.
since
I was just
sorry,
going to say, I
Andrew.
think that's massively important for me anyway. It's good to know how it was done.
Right, exactly. And since their main proofs are all just visual phenomena, then I think it's a good exercise to just go through that and show. I mean, some of them are based on logical fallacies and presumptions, and predicating certain things which are not self-evident and not true.
Yeah.
But some of the stuff, I hope to, at least, gain myself a better understanding there by talking about it, and hopefully it helps others as well. So
Yeah.
I prepared a few slides, which I thought I'll just share my screen.
Go for it.
So if I share my entire screen, I should be able to see something. Hold on, just give me a sec. So, it says dismiss. It says I can't do that. Hold on. Why not? Hold on. I need to do something here to my browser, Dale. Sorry, it's been a while. I need to
It's all right.
put something in my preferences. So,
Cool.
to just take me off for a second, I'll
No worries.
find out what to do here. Hold on.
Yeah, just give me a shout once you've sussed it out, mate.
Come again?
Just give me a shout when you've sussed it out. I'll say hello to the chat box just now. There's a couple of other wee things about, observations that I want to go through, maybe with a wee whiteboard at some point this evening as well. I don't intend to be on all night, but there's a couple of things, as I was just talking to you about earlier, Gav. Things and observations that quite a lot of people miss out with. But I'll get to that at the end.
Okay.
You see, the truth is only relevant to what can be gained from a lie. So why, bro? I don't get what the question is here. You see, the truth is only relevant to what can be gained from a lie. Is this in relation to the earth again? I mean, it's repetition as always with these types of things. There's many things to be gained by having human beings in bewilderment and confusion. Number one, they're going to be in fear. They're going to be stressed. They can be coerced. They can be manipulated. As I say, just look at the ideas that we live as life right now. What do you think's driving this way of life? And it's all based on ideology. It's all based on how humans perceive themselves, the world around them, their place within it. And again, the majority of people don't have a conscious participation or awareness at that level, but they're still being influenced by everything else around them. It's absolutely stupid to be asking, what's to be gained. For a start, you can push, limited resource, never mind the psychology of being, insignificant and meaningless and lost in the void. I mean, these are all mantras and ideas that have an influence on people. If a human being's questioning their very existence and they don't have a proper grounding, the foundation to reason from, like if you start reasoning, trying to find reasons for your existence based on the globe heliocentric model, you're going to go running in circles endlessly because nothing's going to fit. And again, it allows philosophical positions like materialism to be pushed. The attitude of grab what you can for you and fuck everybody else because it's a flash in the pan. Survival of the fittest. Fucking, there's loads of implications for it. But the main one, as I say, use the analogy continually. A farmer puts a fence around the cattle so that he can keep tabs on the cattle. You can't put a fence around human beings. You put a fence around a human being, they're going to want to get over it, they're going to want to explore and get beyond it. But if you can convince a human being that they're on a little ball in an infinite void, then it's the likelihood of them, trying to explore or find what else is there is very minimal. So the cattle are going to remain within the confines of the farm. So I mean, there's loads of implications to that. But for an adult to be on YouTube coming and asking me, a stranger, that kind of question tells me a hell of a lot about you. So if you don't have any comprehension of the relevance or importance of that, that's a reflection of you. I suggest that you contemplate a bit further. Know if there's other lands. And again, I pointed at this ice walls and domes. It's an isolation. And again, it very well may be the case. But, for me, what's most important is establishing what actually is. No theorising an idea of what the Earth could be or it might be or any of that stuff. And again, we just don't know the bigger picture of this, what we're part of here. There could be, if you like, spiritual implications to this, if you want to go that road. Again, nobody has the right to say that reality is just this or just that, whether it be from a materialistic philosophy or a dualistic type philosophy. It doesn't matter, nobody has the right. So there could be any number of implications that we don't know anything about right now. I think it's astonishing that you would ask a question, what relevance is it? If people are quite happy to live in ignorance and live a life of ignorance and bewilderment and delusion, that's up to them. But for me, I ask the questions, what am I part of here? What does it mean to be alive? Where am I? Then I'm going to set out to try and establish that, because I think it's massively important. I'm not just a airhead, I'm alive, so fuck it, I'm just going to make up stuff as I go along in fantasy. That's not me. Well, Alexander, you've got everybody's attention, so you can tell us the points that we're wrong about, since you're crying for attention. So make some fucking sense. Make some valid, salient points. I mean, just the fact that we have restricted areas, we have imaginary invisible lines on land masses where you have to produce paperwork, photographic proof of who you are, so that you can bypass an imaginary line. And again, what if there's other civilizations? You don't know what is actually out there. So, don't ask people who are within the same confines that you are about the relevance or the implications, because we know nothing. All I know is that it's not what they're telling me. So there's an agenda to tell a narrative of where we are, right? And that should be enough for you. If you know somebody's bullshitting you, then it's an investigation to establish what's actually going on. This is your incredulity. But I can't understand how they get all the peoples. I can't understand how they get all the peoples to lie and to... It's because you're a fucking idiot. Right? And don't take it personally, like it's an attack on your person. I'm talking about your intelligence here. You're an imbecile. Right? Because it's the same shit again. Everybody has to be telling lies. Yeah. No, I wasn't telling lies. Gav wasn't telling lies when he assumed it to be true. Same for other people in academia and education that work in branches of the government. Right? Every con that's out there, not everybody that's participating in the con is willful in it. Majority of people, it just bypasses them, like it done for me for the majority of my life, because I missed the relevance by just making the mistake of living on an assumption. So, was I telling lies? 7 years ago when I was running about spouting nonsense that I didn't comprehend about heliocentric gibberish. Boat captains don't navigate by a globe. Right? Who's telling you this? Boat captains do not navigate by globes.
Right, Dale, you hear me?
Yes.
Yeah, it should be good now. Well, I'm presenting, so if you can see it.
Yeah, hold on, I'll just check. Where am I? Fuck, where are you? Right, that's you you're presenting now, guys. Hang on, I'll just share the screen so we can see what's going on. Right, that's you, mate.
Oh. Right, so people have probably seen this picture before, which I think kind of tries to summarise what's going on here. There's an occultation, if you like, of how visible geometry works, right? And they're replacing it with this idea that we're living on a space ball, yeah? Total nonsense, yeah? So I'll just set a bit of context, Dale. This might be a bit of repetition, but I think it just makes sense to go quite a few slides that...
Sorry, Gav, see, just before we go into this, because I'm forgetting, in case there is anybody new here, you know, what's established so far is that, you know, there's two different geometries at play. There's the geometry of the space that we move around in, and then it's how that appears to us through our vision. And that vision has a separate geometry to what the actual space is. Right? So this is where we're talking here about the geometry of vision and how things appear to us in the visible field. And that's it. It's just a quick one for anybody that may be wondering what the fuck we're talking about, or the relevance of this.
Yeah. So the picture I've got up on the screen shows on the left-hand side our tangible world, the world we move in about in. There's a little figure there, and you know, we've got all kinds of objects in our daily life, right? You know, cylinders, cubes, pyramids, balls, blocks, you name it, right? And that's the world we live in, the physical substances, objects, stuff, right? And that 3D world is where we move in. And as you quite rightly said there, there's another visual world, which is different from the tangible world. And that differentiation, or the ability to attend to that difference, to discern it properly, is something that's not easy to do, because we all have eyes and we use them every day. So it's not always obvious to us that there's something different at play.
Yeah.
We just tend to think about the physical objects all the time.
Yeah.
But anybody can see for themselves that objects change shape, depending on your position, the angle at which you're looking at it. So a table doesn't look like a square table from a side view, or from an oblique view. It looks like a trapeze or something completely different, right? So, and the ability to differentiate these two things is really important in understanding how the lie is working. Yeah. So your visual space or your visual perception has everything to do with spherical geometry, which is what we're talking about here. I'm not going to go into detail on the other things on this picture, but so if you like, there's two different geometries at play here. There's the geometry of the physical space down at the bottom, which is everything to do with substance, construction, storage, manufacturing, transport, engineering, mechanics, all the things that, you know, we do in our daily life and people build and construct with, right? Parallels, levels, plumbs, it's all Euclidean geometry. And it's all part, if you like, of natural science, right? And part of our human nature, our lived life, right? Our physical reality. And these things, as far as I'm concerned, are all objective truths, yeah? I mean, anybody can pick up a brick, anybody can play with water. So all these things is something that, you know, they just are, Dale, right? Yeah. And we can all experience them. We don't need to reason about why they're there. We can speculate why they're there and who built them and who made them and all that kind of stuff. But at the end of the day, human life and the world in which we live in, yeah, is, yeah, and we can observe it. We can, discover how the laws are, how they operate, but we don't really have a clue who made them and what's behind it all, right? So, and the top half of this is the geometry of visible space, which, as far as I'm concerned, has been used in things like astronomy, the celestial sphere. It's used in navigation, it's used in dialing, which is like sundials and telling the time and clocks. It's used in surveying, geodesy. So everywhere vision is used to calculate something, or calculate often based on assumptions, then it's the geometry of vision that plays the role. Yeah. And there's different kinds of visual spaces. Spherical is something that people don't realize that's how their vision works. And a lot of that is then changed using language, and mathematics is a language, to give us all kinds of stories about space balls and globes and beliefs and cosmologies. And as far as I'm concerned, all these things are subjective, Dale, right? There's certain truths to certain mathematics. I'm not denying that, right? Like Euclidean geometry, the very fact that it's used so successfully tells us that.
Yeah.
But at the same time, all these cosmologies and space balls and infinite universes, these are all things just based on mathematical physics, yeah? And there's absolutely no proof for any of the stories they're telling us, yeah? So, again, this is the example of a daily life. There's a picture out of my, general world here at the top. I know that fence is really, the square sections, so to speak, yeah, or oblong rectangular sections, sorry, and that the slats of wood, they're all the same, and that the barn here on the left-hand side is also, rectangular. But the way the whole stuff looks to the eye down at the bottom, that's what it really looks like. Well, that's what we're seeing, right? We just don't necessarily, we're not aware of it, Dale, because just while we're looking at that building, we're thinking of a big rectangular barn or a piece of wood that's obviously rectangular.
Yeah.
But at the end of the day, what's being registered to your eye, what's actually on your retina, are these shapes, not the shapes of the real world. Yeah.
And it's one of these things that people don't. Again, it's the same as what I was just talking about before. People don't realise these things until it's highlighted. It's just, again, things that you're born, you live your life, you take things for granted, and people are not paying attention at the level that we're talking about right now. So
exactly.
Yeah.
Yeah, and I think that's why it's easy for people to tell narratives, because if most of the population, or the majority of the population, doesn't discern between physical and visual geometry, then there's obviously a lot of scope there to tell a lot of lies of optical phenomena.
Well, every con relies on the participants' ignorance. So, it's just the same here, just as you say. If you don't comprehend it, you're not paying attention to it, it can be used against you.
That's right. And they've certainly done one on us this time. So I'm just going to skip over this one and go straight to what I think is maybe a pivotal piece of knowledge that will help people understand how this trick is being played, if you like. So here's a definition of a nautical mile from a mathematical textbook, yeah? Mm-hmm. And a nautical mile is defined as the length of the arc of a great circle which subtends an angle of 1 minute at the center of the Earth. So you're supposed to believe that the Earth is a big solid ball, yeah, and it has a center. And a nautical mile, as seen here on the right-hand side in an orthographic view, is then the angle, the length of this arc here. So this very small arc, it's the length of that when the angle at the center is exactly 1 minute. And it's seen here, 1 minute, there's 60 minutes in 1 degree. We usually know that a circle has 360 degrees, and each degree has 60 minutes, which basically makes 21,600 minutes in a circle, yeah? And one of these minutes is then the arc length from the center of the Earth is what they define to be a nautical mile. So that's one definition of a nautical mile. I'm going to produce another one here, which is different. This is a practical definition of a nautical mile, and also the way people navigate on water. So the way it's defined is that a nautical mile is the length or the distance that you need to travel to see a change in altitude of 1 minute of something.
Yeah.
So altitude is basically the visible position of, let's say, a lighthouse. So here's a lighthouse on the left-hand side. There's me at this position, and you, Dale, slightly closer to the lighthouse. Now we are going to see that light in a different visible position from each other.
Yeah.
And if we wanted to calculate the distance between us, if you see that light 1 minute dropped in your visible vision than me, then we know that we're 1 nautical mile apart.
Yeah.
And that's the way people navigate. You know, normally they don't use lighthouses, they'll use the sun or the moon. They'll take a sighting, and that way they can know to travel. So that's the whole concept of the celestial sphere, which I'm not going to get into in too much detail. But the important thing is here, if you distance yourself from an object, in this case a light tower, and the thing drops 1 minute in your visible place, or its visible position in your field of view, then you know you've traveled 1 nautical mile. And that's the way people navigate all around the world, Dale.
Yeah.
Today.
Yeah.
And you'll see that there's these two different definitions are completely different, right? So this one is relying on a mathematical model telling us that we're on a ball and defining what a nautical mile is based on the idea that, you know, the Earth is a radius and there's a ball. In fact, they say that a nautical mile, the radius of the Earth is 3,438 nautical miles. So that's a mathematical concept. And this one is a practical concept. You know, you're on water, we know water's level, and if you move backwards from a luminary or from a light in 1 nautical mile, then it will change its visible position. It will basically drop in your visual field 1 minute, 1 arc minute. So given those two different definitions, the question that really comes up is, which one's real? You know, this is the one they all want us to believe, right? And this is the reality of the situation.
Yeah.
And here's a little bit of text, just, you know, for people who want to follow along. And it, a nautical mile is the length of the arc of a great circle, which subtends an angle of 1 minute. And it also introduces the concept of a radian, which I think I'd like to leave to another day. So I'm just going to use this concept of a radian without completely defining it, and we'll come back to that.
Yep.
But what happens here is that the number of minutes in a radian is equal to the number of nautical miles in the radius of the Earth. And what pops out basically is this number 3438.
Yeah.
So that's what they actually tell us the radius of our space ball is in nautical miles. You'll hear different, you know, numbers depending on whether they use statute miles or kilometers or whatever. But as far as nautical miles are going, that is apparently the radius of the Earth, 3438. And as I say, there's two different, if you like, definitions. There's the mathematical model, and then there's the practical model. So bearing that in mind, and this number 3438, I'm going to jump differently to a different subject, and then we'll come back to it. The different subject I'm going to talk about is visual acuity and the visual angle. So this diagram is taken from a book about 20/20 vision. In fact, it's a book, Dale, that in fact, I think I've got it here. Just let me bring it up. Yeah, I have. This is a book written by an American physics department, and it's to do with what size of letters do you need on an eye chart, right?
Yeah.
So that they are visible. So when you're doing, you know, your eye test, you usually got one of these eye charts with numbers on it, and you stand 15 feet away from it, and you're supposed to, see if you can read all the letters, and they'll tell you how good or how bad your vision is, right? And this document is talking about the size of the letters that you need to draw and the gaps in between them, so that you can draw signs that are clearly visible, and it depends on the distance and the observer's visual acuity. So it's trying to basically measure visual acuity, yeah. And if I go back to the PowerPoint, then one of the important topics in here is the fact that your retina is a curved surface, yeah. And if I'm an eye looking at a chart on the wall, then the question that is asked is, or the definition of a visual angle is this angle here that basically encompasses the whole object. So the object starts at A, it finishes at B. You can think of it as one of these eye charts hanging on the wall. You're at a distance D from it, which might be 15 feet, let's just say, to take an example. And then the question is, what is the angle subtended at the eye from that object, AB? Yeah? And you can work out that angle. On the next slide, I'll just show how it's done. The visual angle is basically the height of the object, or the width of the object if you were looking at something horizontally, but let's assume it's still an eye chart. It's the height of the object divided by the distance from it, gives you the visual angle in radians. Yeah? And again, I'm using this concept of radians without specifically defining it, but the radians is a way of intrinsically measuring based on the radius of a circle. So instead of using degrees and minutes, you basically use the radius of the circle to measure how far you are around it. So if you like, it's something different to degrees and minutes, and it's called radians. Yeah. So this is clear. The visual angle subtended at your eye depends on the size of the object and the distance you are from it. Yeah. And if you want to convert from radians to degrees, there's a way to do that, which I'll just follow the bouncing ball. For those who want to follow along, it basically turns out to be the visual angle in minutes is 3438 times the size of the object divided by the viewing distance. Yeah? So this magic number 3438 pops up again in visual acuity. Visual acuity being how far can I actually see before things are no longer discernible to me. So what's the limits of my vision, basically? And this formula, just to give everybody an example, would mean that if you had a coin of 1 inch of diameter and you put it at 3,438 inches from you, which is 286 feet or 95 yards or 87 meters, right? Then the visual angle of that coin will be 1 minute. And basically at 1 minute, Dale, that's where your visual discernment stops. So some people can go a bit lower, right? Depends on age and lighting and, various conditions. So this isn't exact, but basically if something is less than 1 arc minute, then you can't see it anymore. And anybody can try this, Take a coin, put it at 87 meters and see if you can see it still. Or take a dartboard, it could be 1 meter. You would then have to go back 3,438 meters and you wouldn't see it. So it doesn't really, it doesn't depend on the size of the object. The formula is there all the time. And this magic number 3438 is there in the whole topic around visual acuity. And it just happens to be the number of nautical miles in the so-called radius of the space ball. So people could think this could be a coincidence. I don't think so, right? That basically this ratio of 3438 is where, if you like, the imaginary curve is supposed to happen, Dale. Do you know what I mean? Just beyond our limit of vision, is where the curve starts.
You see this in horizon images of ships apparently disappearing. And it's always the same. You ask the question, well, why does it appear to be a ramping up and then at the point of the horizon it dips away? You know, so as you say, this is the point at where they're saying that the curve is, that's when you're witnessing the curve of the Earth.
Exactly. Yep. I'm basically showing now that the nautical mile has the number 3438 involved, and visual acuity also has 3438 involved. And there's this concept of radians, which seems to be common to both of them. Yeah.
Yeah.
And radians is, as I say, it's a mathematical definition. If you like, it's a generic way of measuring something around a circle or around an arc that is dependent on the radius of the circle to begin with, and not on an arbitrary number like 360 and then dividing it into 60 minutes. I think the reason they chose 360 might have something to do with the duration of a year. If you leave 5 days out for when the sun doesn't change its position, yeah, like at Christmas and at summer.
Yeah.
And 360 is one of these numbers that's easily, divided and multiplied by a whole number of factors. So it was very, how should I say, it's a good thing to do if you're doing calculations.
It's convenient.
But radians is a different way of doing it, yeah? And radians basically takes away any concrete measurement and leaves it solely dependent on the radius of the circle that you're playing with, right? So it's a kind of generic way. It's a kind of abstraction, Dale. So you're not actually getting out anything and measuring a centimeter or an inch, because it's dependent on the radius of the circle that you're drawing. Yeah. So we've shown that there's a connection between these two things, right? That might or might not be obvious to people. Yeah. It's certainly nothing that I ever got taught, Dale, when I was studying this stuff. Yeah. So again, it seems to be tying two different fields, i.e. you going to an optician and getting your eyes measured, right? Yeah. With the stuff they're telling us about an earth ball, and space balls. So one of the things so I'm just going to leave that as a kind of background to the next topic. And the next topic is actually to go into more detail about the geometry of vision and look at some of the, let's just say, the basic things that people should know. And that might actually, after we go through this part, might be a good place to stop, Dale. And I was thinking we should do a follow-up on this, right? Where we go into more detail. So this is the slides I'm going to show now are taken from a book, my favorite philosopher, Thomas Reid, who has a chapter in his book, Inquiry into the Human Mind on the Principles of Common Sense, and that chapter is called the Visible Geometry, or the Geometry of Vision. And what this chapter talks about is basically a proof that your vision is spherical. Yeah, it's got nothing to do, it's not Euclidean, but the fact that your eyes are globe. I mean, it's kind of obvious when you think about it, right? The fact that your eyeball is spherical, but the geometry of vision is also spherical. Yeah, so let's just go through it. There's a couple of things that people just need to remember when they're thinking about this topic. So the first thing is always to imagine that your eye is at the center of a sphere, and a great circle of a sphere is basically, if you cut a plane through a sphere or a ball, then where the plane meets the surface, you're going to have a circumference, a circle made, and that circle is called a great circle. And if you were at the center of a sphere and you looked at that great circle, you would not see it curved. Because you're looking straight at it, you wouldn't see its outward turning or its outward curviness. You'd see a straight line.
Yeah. So what I was trying to make, just to add in here, just to inject this in, if people had a nice shaped hula hoop, so made of metal, nice and flush, and you turn the hula hoop up on its end and place it in front of your eyes, you're just going to see a straight line. You're not going to see the outward curve at the other end. Or even if you were in the centre of a hula hoop and you lined it up to your nose, You know, you're just looking at a straight line. You're not seeing the outward curve that goes around the outside of it.
Exactly, and it's the same for your horizon, basically.
Yeah.
You know, if you look around you, all you need to do is turn on the spot and let your eyes travel round with your head, and you will also have the impression that everything is a straight line.
Yeah.
And what you've done is turned a circle. So again, that's a great circle as well. The horizon around your eyes, and for us, it's a straight line.
Yeah.
And the second paragraph that says here, and it's important to note too, that if you put a plane through a sphere, and on that plane you draw a squiggly line, then again you won't be able to see that squiggly line, because again it's like side on to you, right? You're looking at it, even if it was whatever kind of curves, all you'll see is the points as if they were organized in a straight line again.
Yeah.
So it doesn't matter whether they're straight or curved, they'll always look straight to you. Yeah?
Yeah.
And it's basically because you're at the center of a sphere, and these things, you cannot see the curvature because you're looking directly at them. So that's, one of the main propositions, let's say, of the geometry of vision, that you, how should I say, understand or comprehend this part, right?
Yeah.
And I think it's similar to also if you take a pencil, Del, and you put it out in front of you, then all you see is a point, right?
Yeah.
You see the end of the pencil, you don't see the line, right?
Yeah.
So similar stuff.
Yeah. I was just going to jump to the whiteboard here just to show what Gav's mentioned. So, we got a circle, you've got a squiggly line like this, right? Obviously for the orthographic view, but if we were to be looking at it from this point of view, looking at it here, it's going to appear like that. I know that's not a perfect straight line, but that's what you're going to see. You're not going to see these peaks and troughs. Same for the circle, you're just going to see a straight line looking at it from that point of view. It doesn't matter if you do it vertically or horizontally, it's the same principle. So.
Yep.
That's you back on, mate. Sorry, I was just showing it on the whiteboard there.
No, no bother. We got whiteboards now.
Digital
whiteboards.
We got an online digital whiteboard with squiggly lines.
So I'll just go on to the next thing. So when we talk about, I hope the PowerPoints or the slides visible. Yeah.
Yeah.
So when we talk about a visible right line, then we're talking about always when the word visible is in there, then it's what we're seeing, right? So I'm looking at a visible straight line, and it's always going to coincide with some circle of the sphere. Because if you have a line, Dale, and you're looking at it, then the outside arc of that line. Sorry, I know we don't have a picture to show here, so I hope the words themselves will get it, or we'll see an example in a minute. But they'll always coincide with a great circle of the sphere. And when you produce those lines, so like what I said about the horizon, it will appear to be a continuation of itself, and it will return on itself. Yeah. So the example I gave of me just standing there and turning on the spot and looking at the horizon, it's a straight line. It joins up in itself, right? And it's a continuation basically of one line all the time. Yeah. And the eye doesn't see those objects, or it's only the position that it sees with respect to itself, and never sees the outward distance.
Yeah.
So the points on a great circle will have the same visible place as the points on the line will have. So maybe it'd be better to have a diagram for this, but I hope everybody can maybe just come back and read this themselves until they've understood it, or they can ask questions or whatever. But these 2 points are important.
I think we do need to keep coming back and visiting this and continue it on as a series, Gav, to be honest with you.
Yep. The main thing is that both, because the points in great circles have the same visible place as the points on the line that you're seeing, then basically everything can be represented by the great circles of a sphere. So here is a diagram which I hope kind of makes it a little bit more obvious.
Yeah.
Here's a great circle around the sphere. You can see that the points on that sphere are basically the representation of that line, which is drawn on a plane, in this case, below your feet or below your eyes, yeah? But you can see that that line is perfectly represented by the points on the great circle. So every line has its own representation as part of a great circle.
Yeah.
Yeah? It doesn't have to be a full great circle. It can be an arc segment of a great circle, but basically every line will have that. Yeah. Now, if you have two lines, like let's say there's another line there, then it will also have its own great circle. Yeah. So you could imagine this diagram having two great circles, not just one, and you're maybe looking at two lines. Then there will be two great circles, basically, on this sphere. And basically what we're saying is, if you see the angle of these two lines that are drawn on the ground, it's the same angle as the spherical angle that the two great circles make where they intersect. Yeah? And this is a well-known fact. This is a very important slide, this one, and the text that's on it, which basically summarizes what we've said. And this is something that mathematicians know, that the visible angle that comprehended under two great circles when seen from the center is the same magnitude as the spherical angle which they really comprehend. So on a ball, yeah? So if you're looking at something from the center of a sphere, then the visible angle made by two great circles is going to be the same as if you measured the spherical angle on a real solid ball. Yeah? And that might sound trivial, what I'm saying, but it's a really, really important point to understand how the trick works, yeah? Because if you think back to this definition of a nautical mile, i.e., we're supposed to believe that we're on a space ball which has a center, yeah? But what they're really selling us, yeah, is the geometry of vision. They've just packaged it differently, Dale, yeah? Using that this slide here basically gives most of the game away. Yeah. If you understand this part as mathematicians do, then you also realize how they can quite easily swap out the one for the other.
Yeah.
Because the angles they're measuring, the visible angles, think back to, I'm on the water and a lighthouse is dropping its visible position. Yeah.
Yeah.
And if there was two lighthouses, then I could draw a line and I can measure angles, right?
Yeah.
Or with a sextant. They're basically saying that on a ball, the spherical angle will be the same as that visible angle that you've done.
Yeah.
So that's how they can get away with putting you or saying that it's the same as a ball. Yeah. And they've even made the definition of the nautical mile such that it works.
Yeah. So
I hope that makes sense. So it's a complicated subject.
So get back to the whiteboard again. Where's my rubber? Wait a minute. Just quick, just so I can. Wait a minute here. What's going on? Let me put this away up here so I can rub this out quicker. 2 seconds. So for me, what Gav's saying here is, and just stop me, Gav. I don't know if you can see me on the whiteboard here.
I can.
Right, okay, right. So, what Gav's saying, we've got the lighthouse here, we've got the observer here, and there's an angle, right, that you're looking at it. Right. Now, as you move back to here, obviously the angle's decreasing. So what's being done is that this is just based on the arc of your vision that this is happening, so you can see that there's an arc here of the outer portion of your vision, but as you walk back, what they've done is they've made you think that you're walking backwards over a curve. And is that right, Gav? Am I right, correct here?
Aye, aye.
So it's just a switch of the two geometries again, and superimposing that it's a physicality of you moving around a spherical object. Am I right?
Yep.
Right.
Absolutely.
I'm just trying to do it quick here, you know, with this squiggle, but
your artistic abilities are pish.
you do it with a mouse.
You really need one of these tablets and pens.
So I mean, you know, as you walk back on a level surface, the top of this is appearing to you to drop. So now that you're back here, the top for say would be appearing here, right? And what we're talking about is vision and the angle of vision with the outward arc of your vision, right? Because you're not seeing this curve point, right? You're just seeing the inside of it, if you like. But as you walk back, rather than this dropping in the visible field, they're trying to make you believe that it's staying still. But what's happening is you're going backwards over a curve, so this appears to drop due to you walking, back over the curve of the earth. Correct?
Yep, and it's got nothing to do with curvy spaceballs and everything to do with how your vision works. Yeah, because the spherical geometry is the same in both, and it's just a matter of making definitions and using the language to tell the story. Yeah. So if I was to go back to the one about the visual acuity, where was that slide? Yeah, so this visual angle, the size of the object and the viewing distance. You've heard the old story about the moon is apparently, a lot smaller than the sun. They just look the same size because one's so far away.
Yeah.
So if you're obfuscating angles, or you're using angles in this concept of radians to measure things in astronomy and celestial sphere, then you can tell lots of stories about the size of the object and the viewing distance to make it fit, Dale. Yeah. Whereas if you're standing in front of an eye chart, you know it's 15 feet, and you know that it's 5 foot tall or whatever how tall they are, I don't know, right?
Yeah.
So, getting back to the fact that we can walk to the chart, right? We can measure its dimensions using a ruler. We can pace the distance, So it's all right to use it in that respect and to talk about visual acuity, but it's very easy for them to use the concept of radians and talk a lot of shite about the size of objects and the viewing distance, Dale. Yeah. And again, that for me, that's where the trickery comes into play. I think the next thing I'd like to do is dive into this concept of radians, and unfortunately, it just gets a bit mathematical, and I'm assuming that there needs to be a certain amount of knowledge right around mathematics, which makes it kind of difficult to convey to everybody. Yeah, but I'd like to try my best the next time to go through this concept of radians so that it becomes clearer how they're making this trick.
Yeah.
So if I go back to the geometry of visible space and the geometry of physical space, making sure that you understand that difference is absolutely imperative, right? And that they can get away with using it in astronomy and navigation only because they're actually using visible space to do their calculations, the geometry of vision, rather than the geometry of any real spaceball, Dale.
Yeah.
And the concept of radians plays a big part in that.
Which again it's backed up by the very fact that they don't have a direct measure, as we were saying at the very beginning of this. There is no direct, tangible measure of the curve of the Earth.
No, absolutely none.
Yeah,
so that's all I've kind of got as a kind of way to get myself back into the swing of things, Dale.
Oh, nice one.
To say it's been a while, and I just thought it makes sense to revisit this topic, and I'd like to dive in a little bit more into some of these mathematical concepts, and hope that I don't lose people along the way, because I know it is not a simple thing.
To be honest with you, if people are really curious and interested about the nuts and the base of this is where you have to go. So there's too many people out there that are just interested in entertainment and pacifying themselves for selfish reasons. But if we want to get at the root of this whole thing, then this is where we need to really go.
Well, I think it's imperative that we wake up the people that are in the science field, because again, even though I know that there's a lot of corruption and nonsense done there as well, Dale, I still do feel that people with integrity inquiring about the nature of the world, they don't know this stuff and they don't make the discernment between visible space and physical space.
No.
And if they did, then we might have more people in the science world coming out and understanding and realizing this whole con. Yeah,
it's no part of the curriculum, and getting back to what that person was talking about earlier, and people telling lies and blah blah. They just don't comprehend this stuff, and just because they're in academia or they've got PH, whatever after their name and letters, it doesn't mean to say that they've contemplated or even reasoned with this stuff, because it's not been made relevant to them. Because obviously they're born into the same situation that we are, and they're just operating from the assumption and the ignorance of that assumption, and they just continue on their path, rabbiting and repeating from that perspective. But this stuff that we're talking about now is demonstrable. It's a fact, that we're talking about two different geometries. There is a definite geometry vision, and how anybody can possibly try and deny that is mind-boggling. And then it just becomes a comprehension of how do we separate the visible space for the physical space.
And I'll reiterate what you said many a time. Anybody who is not taking visual perception or the geometry of vision into account in the explanation of any of their optical phenomena for their proofsies is just ignorant, or not being honest. One of the two.
This is why the globe proponents are continually showing people orthographic projections of, we'll say fence posts, and asking questions of perspective views of how something taller than this one can appear below this one, and because they're flipping between the geometry of physical space and how objects actually are in the visible space, then omitting that there's a geometry to vision, and then making assertions and statements about what we should and shouldn't see, in the visible field, without accounting for the visible field and how it's actually functioning.
Absolutely, and this jump to an orthographic view denies how we actually look at things. We look at things directly, Dale, in a globe, like at the center of a sphere. So jumping to an orthographic view it implies that you've got some kind of godlike powers to be able to, extract yourself from whatever it is you're viewing, all the way out into outer space to be able to look down at that, which you can't, I mean, one, because it's not real what they're telling us, and they tried to give us these kind of godlike abilities, if you like, to sell us then the stories.
Exactly, and the orthographic view is perfect for us in regards to construction and these types of things, because it works for us. That's how the world functions. But that's to do with tangible objects that that have a direct measure. Totally different from how it appears to us visibly.
Good. I hope that kind of made sense to folks who may be hearing it for the first time, and for anybody who's already heard it. Repetition goes a long way sometimes to helping understanding or just talking about it. So,
well, I often wonder about new people. I keep seeing a lot of social media, TikToks and whatever else, and there appears to be a new wave, if you like, of people coming into this topic. So, again, none of us have all the answers, and it's good for me, it's good for you, Gav, to go over this stuff and continually push to see, where it takes us, because. For me it's pointless arguing and debating about flat earth, globe earth and all this other stuff. If we're going to use visible phenomena, or ships go over the curve, ships don't go over the curve, we see too far, on both sides of the dichotomy, that people are still admitting that there's something that has to be looked at here in regards to the geometry of optics. So
exactly, I think it applies, as you say, to both globe believers and if you want to call them flat earthers or people who don't believe the globe, this part is, if you like, for most people, it will be the missing link. again, it's not a proof of anything. Water
No.
already proves, that they're telling us lies.
Yeah.
But the how, how they've done it and how they're deceiving us,
Well,
this has a huge role to play, Dale.
Well, that's the power. That for me is the useful aspect, because we need to comprehend it. If we don't, then we've not resolved anything. Obviously we can see contradictions in what's been professed to us, but it still doesn't give us a full grasp of how they actually got there in the first place. So,
and knowing that will help us stop being deceived in the future.
Exactly.
Using the same kind of thing, because I don't think it's the only place where the occult, if you like, the geometry of vision, to be able to tell the stories.
Yeah.
There's other examples which we can maybe talk about too, but this is obviously the main one to sell us this nonsense story.
Exactly.
So it would also, understanding it will help that that they can't do it to us in other places.
Exactly. Well, there's no point in knowing that you've been lied to without fully comprehending how, because in the future you're going to succumb to it again. It's like the con man in the street, the trickster. The only way you're going to stop that from happening is knowing how the tricks are done. And once you know how the trick's done, it doesn't work on you ever again. So
that's exactly right. And we need to get it into the education too, because once we're dead and gone, they've got another generation which they can deceive. If this stuff is not made widely available, right, and taught properly. And I mean, not just this. I mean, there's so many examples now in education where you have to scratch your head what the fuck they're talking about and what they're doing to our kids. But this would be, for one, at least in the natural philosophy field or natural science field, that is a must. Yeah.
Aye. Let's stop talking to our kids about fucking gender nonsense and get to the nitty gritty.
Yeah, I mean that's pretty. I mean, topics like gender or identity generally has also been a big topic of philosophy for 300 years, right?
Yeah.
What does identity actually mean, right?
Yeah.
What is the contents of consciousness and all that kind of thing? But you can see how it's very easy for them to get into schools,
Yeah.
Talk nonsense with these like gender identity or fluidity, and just totally avoid objective reality.
Exactly.
And inject them with subjective stories,
and they get there by playing out the victim aggressor type roles. These poor people have been oppressed and blah blah blah, and they come at it from that angle, trying to make you think you're a better person and yada yada. Again, as you just said, Gav, for me, subjectivity is a realm of metaphysics that is, murky, and there is no resolve there, because that would suggest that somebody has access to leaving this reality to know what encompasses it as a whole, the rules, the blah blah blah. Nobody has any of that, and it's subjective, it's no objective. So for me, it's totally irrelevant, and should never be brought into the public arena or pushed as any sort of agenda, a topic of discussion. To me, it should just be totally irrelevant. Subjectivity should be private, end of story.
Yeah, and I mean, you have to include all religions in that, because, I mean, I can fully understand why somebody who sees the physical world, understands human nature, still has the question, where the hell did it all come from, right? I mean, even if there is a God, he must be asking himself the same question, Dale, right? Where the fuck did I come from? Where am I, right? So you have that kind of, it's something that will never be answered properly, and it's all inside your own head, and it's a very subjective thing what you want to believe, right?
And why would you want it answered is always my question. It's no use to us. You don't want to know all what you're going to do with that. It's ridiculous. It's preposterous. I think that's part of the trick. Is, as I said before, in the scientific community, they've got people trying to zoom in on the micro and zoom out to the macro, and we're missing the point of experience, the point that we actually exist at, that we all share from day to day, the point of experience. It's totally irrelevant to have us gone in these directions. Trying to establish at the smallest of levels what matter is to the macro level, and the same with consciousness and subjectivity. We don't have access to these things, and they're irrelevant to us.
Yep. I think most people don't enjoy the experience, and get caught up in the whys and wherefores, and get dragged into these religions and beliefs and cosmologies. And I do think it's detrimental in the most part. I mean, everybody loves a bit of metaphysical speculation, but you come to a point where you realize you will never be able to fully know, right? You're not the only one that's tried, and there's going to be people after you that'll try as well, but you won't ever be able to figure it out, Dale. I mean, the only possibility of finding out more would be to find the actual extension of where the fuck we live, right?
Exactly.
To see, what are the boundaries of this place we call the world, our physical space,
Because going back to the point of the person earlier, if we establish that, then we've got clear grounds. If we get exploration, we establish we're in some sort of containment, blah, 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 then at least we know where we're at. Then we can contemplate, well, what's next then, what
would be a good society structure or set up to be able to live and enjoy it,
If we establish we're in some, definite containment and there's a limitation to that, then fine, let's come up with a better idea of ourselves, and have that established that it's only an idea of ourselves, it's no anything objective again, and people get caught too much up in that, trying to define and explain their existence rather than just moving through the experience of their existence like it has a relevance. And I've always asked that question, what's the relevance of trying to define my existence? All I'm equipped with is to explore at the experiential level what actually is, and that's it.
Yep.
So
absolutely.
Just another quick point that I'm going to make on this. Oh, what's happened here? Let me get my ruler out. What's happened here? I just want to give a wee quick explanation to people, and I'm going to go get a video that this is related to, but I just want to make the point quickly here. So, if you're a person, I know this is shite, and you're looking straight out, right? Now, where your feet are planted, right, on the ground, you there, Gav? Something went wrong here. Oh shit. Let me just fix this here. Sorry, Gav, I clicked the wrong fucking thing there.
No, no bother.
You there? Aye, you can hear me.
Aye, yeah, I can hear you again. Right.
Right, so I'm back here at the whiteboard. So if you're here as the observer and you're looking straight out, right now, I know we've got an orthographic view, but I'm gonna draw this in. So it appears to us that the floor rises up and the sky descends to this point that we would say the vanishing point, or I would say the centre of your vision, right? Now, if you're standing on this plane and you say you're standing in front of, we'll say, a mountain, and that mountain extends way up and beyond you, right? See, because the base of the mountain is on a plane beneath your eye, right? As that mountain goes off into the distance here, right? It's always going to compress to beneath the centre of your field of vision, right? Because its base, its foundation is on a plane beneath the centre of your eye. Your eye is always above its foundation. And it's the same if I had, we had a solid ceiling here and something lowered down and come across the centre of your field of vision when you're right in front of it. The same again, as it goes off into the distance, it's eventually going to come above the centre of your field of view, right? Because your eye, the only way, like if we're here and we've got a mountain here, right? The only way for the mountain to stay in the centre of your vision and never, for the top never to go beneath the centre of your vision, is if your eye is submerged on the same plane as the base of the mountain. So your eye would have to be sunken into the earth So half of it was above the Earth and half of it was below. Then as that goes into the distance, it's never going to compress to the lower portion of your vision. But because your eye's always above, then anything that's attached to the plane beneath the centre of your field of vision into the distance is going to appear beneath the centre of your field of view.
Absolutely. Yep. Spot on.
Right. And I'm going to leave it at that for another video where I'm going to highlight where people can go wrong and people have went wrong in regards to these observations. Anyhow.
That would be a good topic, because I think people always get confused at that point and let themselves be swayed by arguments that photographers take about whatever, seeing Ailsa Rock or whatever, Dale. Yeah. And I think again it's because they don't quite understand how this whole vision things works, that they so easily get trapped or fooled or deceived. Yeah.
And the rate and the compression of, say, this mountain compressing to the lower portion of your field of view, as you elevate up higher, it becomes even more pronounced. Right? Yep. So even if something's 20 times the height, say 1,000 meters above your 6 foot height, eventually it's going to compress. But if you then elevate up, it's going to compress even more to the lower portion of your vision. But I'll save that. I'm going to leave that for another time. Aye. Where are we at now, Gav? What are we talking about now?
Anything you want, my man. What's going on in the chat? I haven't been in the chat for a long time. Let me say hello to everybody.
Aye, go for it. Aye, exactly, old dude. It's people that ranty. We've seen it years ago with the guy Miles Davis, and they resorted to cropping images and manipulation. And again, they just omit these factors. And again, what I've just shown you in that drawing, you can recreate on a smaller scale for yourself. So if you've got a camera lens, right, and you've got an object in front of you that's taller, right, and you take it away, eventually that whole object's going to compress to the lower portion of your vision. So imagine your eye in two hemispheres, right? So anything that's attached to the plane beneath your eye is always going to compress under the centre of your field of vision eventually with distance. And it's the same for something that's above, coming across the centre of your field of vision. As it goes in the distance, it's going to come above the centre of your field of view. Dale just threw up the 666. Whatever. It's difficult to make circles without. It's just.
Yeah, Mason. Yeah, big bad Mason, yeah.
Well, DJ Brownie, that's the whole point. Really, if people are here and they're invested in this, or apparently invested in establishing the truth of this whole topic, then again it has to go here, because this is what the globe is based upon. I implore you to go and check yourself. There is no direct measure, there are no practical physical demonstrations for any of the globe claims. It is all based in optical phenomena.
I think another topic that would be good to show is the whole concept of time and how we measure time, Dale.
Yeah.
Like what's a clock face, how is perspective and the measurement of shadows and things like that. How is that used? Because it has a tie-in to this whole topic as well.
Yeah.
And the stories they tell us about the sun and the moon and the stars moving and how time is measured, all ties into motion again, yeah?
Yeah.
And what is actually moving, yeah? Exactly. And what's not moving. So I think that would also be a topic, sundials and clocks, that we should look at.
Yeah. I will incorporate it into this whole investigation, the globe vision, geometry of visibles. We should just incorporate it in.
Yep, I've got a few other themes already, which I'll prepare for the coming months, the coming winter months.
Yes, we'll get plenty of that to come.
Yeah, it's going to be dark now. I think the clocks are getting moved next week, is it?
Next weekend, aye. And it's funny again that, like when you look at the difference of that, it's only 5 months from when it goes back to when it goes back forward again, but 7 months the opposite way.
True.
So it's the last weekend in March it goes forward, and the last weekend of October. But from March to October you're 7 months there, and obviously from October to March you're only 5.
Yep.
So, I mean, I don't know if there's anything else you want to talk about here, Gav, or we'll just leave it at that and we'll continue on whenever you've got the time.
Right, I'm good to leave it at that for today. Yep.
Cool.
So maybe just one point, I think that it's something at least that I've never really, how should I say, properly understood the meaning. This, what's the best way? Do you help others before you help yourself, or do you help yourself before you help others? One of these kind of nearly moral questions, right? You feel you should be helping others, but at the same time, I don't think you should. If you haven't helped yourself enough to know your own mind, Dale,
no,
and understand your own beliefs, you shouldn't be going out spouting them to other people.
Exactly.
Or trying to help them, or what you think is helping them. Yeah,
exactly.
Certainly something I've come to terms with. Right, when you're young, you tend to just spout out, what you've heard or repeat without having really fully understood or comprehended why you're saying these things or what you're saying.
But again, as we've pointed out before, it comes from, I think, a place of good. It's just a bit of naivety and inexperience where people jump. Their intent really is they want to help other people, or to them they think they're going to help other people, and it comes from that place. But if you're not balanced, it's not going to serve the other people well. So I get it. A lot of people get excited, they've learned something new, they want to convey it, but they jump in with unnecessary drivel attached to that, and that again, it's not because they're bad people or we have to demean them in any way, shape or form, but it's a learning process that everybody has to get through. I think I kind of lost my train of thought there, but
no, but you're quite right. That's what I'm trying to say too. It comes from a place of good intention at the end of the day, but it can be more harmful than good. If you don't know your own mind and how the body works, and
exactly,
before you go out and teach and profess and share and like and repeat and force your beliefs onto other people, you really need to understand various things. And
exactly.
So,
and there's no point about talking about any kind of topic if you don't have a full grasp on it, because what's going to happen is a question may come your direction or whatever, and you're going to stumble and fumble, and that can be enough for people to say, oh well, look at you don't even know what you're talking about, so therefore I can rubbish every aspect of what you're talking about, which is how people operate. That's the way people are.
That's right.
You can say 99 things that are correct. As soon as you say something wrong, boom, people want to jump on it and focus on it and utilise it as a way for them just to discredit everything. Because again, people don't want to face up to these things. They'll look for any avenue to run away from taking responsibility and no looking at it.
Yep, especially if it is a difficult topic to attend to. Yeah. And I do think that vision is one of these things where you really need to focus on. Yeah. Pun not intended. Sorry.
Right.
All right, my man. I think I'll call it a night. I'll let you get on with it.
No worries, mate. I'm just going to, a wee quick 5 minutes in the chat and then I'll be off. So appreciated for your time, mate. Cheers for that.
It was great talking to you again.
No worries, mate. Skis a shout.
Speak soon.
Right,
cheers,
mate.
man.
Cheers, bud.
Bye.
whiteboard down. A digi whiteboard. I'm going to stay on for another couple of minutes. Any questions, any points? As I know, say you wish you could get some discussions with globe earthers. Well, it's very difficult if you're talking about online, because the majority of the people online are characters. They're part of a circus. They're not here for honest discourse and rational discussion. They're here to push their, religious belief in something that they want to be true. Whatever their motivation is, that's only they know. I'm really not interested in it. Again, the proof's always in the pudding. I can tell by the walk of people what their intent is, and I've seen these characters over and over again. They come with the same rhetoric, they come with the same mannerisms, the same attitude, and you have to be willing to deceive people to keep pushing this globe narrative, and only a certain types of people will do so. Again, you can see the contrast, and it's massive, between interactions of online globe priests to the interactions of the normal everyday man and woman in the street. Totally different. So if there's any globe earthers out there, as I always say, get in touch with me. We can arrange a meeting, we can have a discussion, we can film it, we can, whatever. I always think that it's a useful tool for people, particularly people who are still coming to it, that are maybe sitting on the fence asking questions, and if they can see two, from their perspective, two different perspectives, they can maybe get some clarity out of that. But it requires people who have the ability to actually have a rational, discussion. So if you're a globe earth believer and you think you can articulate your points and we can have that discussion, by all means get in touch. It's always a benefit to other people. No, Trackmatic, again, I'm well aware that any type of movement, so even something that's based in truth, we'll look at this, we see an infiltration, we see corruption taking hold. For me it's not about rubbishing every aspect of everything, but it's having the ability to identify where the bullshit lies within any sort of doctrine, whether it be religion or whatever. I don't have that attitude. I think I've made it clear by now. I don't just jump in bandwagons and hand wave, dismiss and generalise everything into one box. But I can see the pros and cons of some of these ideologies and their usefulness. Aye. No, Globe Earth explanation is a complete opposite of Occam's razor, totally. The Globe Earth wants you to, ignore your direct experience and your common sensibilities in favour of outlandish beliefs and, fantasy. You've got to suspend your own direct experience in favour of something that you do not experience. So it is a complete opposite of Occam's razor, Well, it only appears to be level and not moving, but it is, and it's gyrating and wobbling and spinning and going 4 different directions all at one time, because your senses are flawed. But us that are telling you that, our senses are not. We are special peoples. Tony Whitcomb, beyond the curve, orthographic view is to imagine what you don't see into existence. Don't get what you mean, Tony. I was utilising the orthographic view, an orthographic projection view, like an engineer or a construction, a builder would use. If I'm going to erect a wall with posts. Then I've got my projection of my drawing, and I know that these posts need to be 1.5 meters, and then the wall drops to 1 metre for a span of 5 metres, and then another post at the same, and you see that as an orthographic projection. But once you've constructed that, then you go to the side and you look at it. That's not how it appears. I don't get the point you were making. Sorry, I must have missed something. What's your motivation to keep on doing this? Why would nobody be motivated to try and uncover what the truth is of their reality? Because I'm aware, I'm a conscious being, that's my motivation. I don't have anything else invested in it. I don't have an agenda. I'm not doing this for, some other purpose. I'm a conscious entity that's asking questions about what it means to be alive. That's my motivation. Yep, Imran, it's always the same. Yep, so an alien science should never be blood with religion, which is exactly what has happened. That's Phil B to tell us there's little lights in the sky, so therefore the Earth's a globe. Nice one, Phil B. Great depth of reasoning there. Exactly, Bristolian, but you have to suspend the fact that water, surface of standing bodies of water doesn't bend. Because Phil B wants you to look up at the sky and see little lights, and then switch your TV on so that they can convey to you what these lights are. And the fact that it's in space can run a little fucking planetoid. Although your experience is that you're on the level, and that the surface of water is level everywhere you go. But you have to ignore that, because there's special priestly figures like Phil B in the chat who want you to look up at little lights in the sky and correlate it by what the TV tells you, because he's a genius, very rational, very sane being. Don't trust your senses, trust Phil. No, don't trust what you experience, trust Phil. Phil's going to tell you what your experience is, because Phil fancies himself as a superior, a godly figure, because he's fucking cuckoo. We need some fight these flat earth. Still waiting my contract, Helen Degenerates. I'm still waiting this lawyer's fucking thing or whatever the fuck Fat Tits is trying to come up with. It's all went silent. It's one of these guys who just likes to bump his gums and then glean some sort of attention from his little minion followers as if he's stood up like a man to be counted, when the reality is it's just hot air and no follow through. Muppets. Absolute fucking Muppets. Water can never be flat as she possibles. Whatever, Phil. Any moment now, Phil's going to offer us a practical demonstration. In fact, let me just show you this. Shown ones like this before.
Tap. You always have 100 degrees boiling, filtered, chilled and sparkling water, all from one tap.
These days, if you want to simulate something in the physical world, you use a computer. But what if you couldn't? What?
Yes, these days if you want to model something in the physical world, you use a computer, because we need to portray that it's globesies. Right? This is an actual true scale model of a section of Earth with absolutely no fucking curvature whatsoever. Right? A true scale model. That being that it's made of actual physical materials and there is the substance known as water contained within it, displaying a nice horizontal level surface everywhere, because that's the datum that they would have utilised in order to construct this very model. A plumb and a horizontal. The horizontal is represented by the water level. Right? This is reality for people like Phil. Well, what is never flatty? It's curved. Okay, so when we're utilising true scale modelling, there's curvature here, so we should be able to directly measure it then, Phil? Oh no, excuse, words. Think of some fanciful words to handwave dismiss the tangible real world and how it actually functions. Go back to your TV and look at little lights in the sky, Phil. Tatty buys.
What if it was, say...
Anyhow, I'm off ski. I'm away. Take it easy. Thanks for being here, everybody. We'll see you very soon.